We are going back to the moon for the first time in over 50 years in hopes of using the moon as a launch pad for human space travel. This really got me thinking. What does this mean for the future of space exploration? And what do people think about this? To answer my questions, I interviewed Doug Bernard, a former engineer at the Jet Propulsion Laboratory, which is a leader in robotic space exploration. Doug shared his own personal thoughts on the future of human space travel and what he is looking out for. I was fascinated. Note, his views are entirely his own and do not necessarily reflect those of JPL. Now, let's get straight into the interview. Okay, so first one I'll start off with is, do you think that human space travel is inevitable?
I think that it is. The humans are naturally curious and will find a way to go over that next hill or see what's across that ocean, and space is a place like that that humans will want to go to, but it's much more complex and difficult to get there. So there's a cost involved, and so it's not inevitable this decade, but I think it's inevitable over time. And I think that travel, outside the Earth and thinking about what's outside of what we already know is good for us as a people, and it can be inspiring to a lot of people. And although all of that I've done is robotic spacecraft, and so that means I'm biased. I've been thinking about how to do things with robots. There's something very engaging about human exploration because it allows people to think of themselves as going to other planets and other worlds. And so if a human exploration program gets people excited about space, well, I like that too.
I know you did more stuff like about other planets, but I have a few questions about the moon, like upcoming moon mission.
Sure.
Why do you think it's suddenly now that we have decided it's the time to go and explore the moon again? Why do you think it's taken this long, and why now?
There was the big push for the Apollo program, and then after we'd sent several missions there, the public kind of got bored with it, and didn't want to spend that amount of money on a continuing basis. Quite reasonable. No one expected it would take this long to go back. At this point, the infrastructure that was used by the Apollo program to get to the moon doesn't exist anymore, and the machines that were used, to build the Saturn V rocket, those don't exist anymore either. So we can't just make another Saturn V rocket or another Apollo. So we really would need something new. But the problem is that Mars is so much further than the moon, that there's no obvious next mission that's further away from the moon, but not as far as Mars. But so it's too hard to get to Mars with humans right now. And if you do go to Mars with humans, well, you'd want to practice somehow. So for people who think that Mars is the next step, well, we have forgotten how to go to the moon, and so we really ought to do that first. But in order to fund things like this, if you call it practice, you'll never get funding for it. And so it's important, I think, in order to keep the public interest, that there be something that we really want to do at the moon. Otherwise, why are we going back just to do it again? There is something new, and that is we recently, by reanalyzing data from some moon orbiting missions, we discovered that there is water on the surface of the moon, water ice on the surface of the moon. And you might say, how is that possible? Wouldn't it boil off or sublimate in the sun? And the answer is, yes, it would if the sun ever hit it. But if you go to the South Pole, there are some deep craters where, whether it's summer or the winter, there's part of the crater that the sun never gets to the bottom. People had thought for a long time, I wonder if there could be ice there. And the answer turns out to be yes. There is dirty ice down in the bottom of the crater at the lunar South Pole. And plus, all of the missions that we sent before were missions sent to the lunar equator. The idea is send people to near the South Pole of the moon, where we can start, getting ready to understand what's in those craters.
If space travel became widely available, would you choose to live on Earth or go to travel to some unknown planet to live there?
Okay, well, in fact, that's a very insightful question, because I was going to say that when I was much younger, I would have been very interested in going to, or exploring the idea of going to another planet, but not an unknown planet. But I did want to know a little bit about it before I went there. At my age, I've built my life here. I've got my husband, my friends, colleagues, and community are all here. And so at this point, I wouldn't. But earlier on, definitely.
I was just kind of curious. I don't remember what your questions are, but like maybe what would be something that you specifically would want to explore, or is there an actual planet that you wished you could actually step onto and explore?
Well, as I've learned more about them, they're divided into a couple of categories. In terms of to step on them and explore, I think Mars would be the best. Because it has because we can move around on Mars, and the environment is I mean, we need spacesuits and so on, but the gravity is reasonable, the radiation is reasonable, the temperatures are manageable. Some of the most exciting places to go would be to some of the moons of Jupiter and Saturn, where they've found liquid water. But the liquid water is beneath miles of ice, and they're very cold. And for the moons of Jupiter, the radiation is just so intense that humans wouldn't last long close to Jupiter. It's difficult to build robotic spacecraft that survive there, but those are Europa at Jupiter and Enceladus at Saturn are two of the most intriguing moons for me in terms of, wow, might there be a possibility of life deep under ice in the liquid water?
How do you feel about putting man-made objects on the moon or other planets? I mean, I know you worked with that stuff, but just
yeah. Well, I've done it, and I didn't feel bad about it. So I think it's I don't have an objection to it, because there's the possibility of life on other planets that might be different from life on Earth. There's some set of rules called planetary protection that are designed to limit the amount of contamination particularly biological contamination that we bring to other planets where there's a possibility of life. And so I think that those are important rules. And so we're being somewhat careful, but when you put human-made things on another planet, you will contaminate it somewhat. But I see it as part of expanding our knowledge of learning more. And I understand that other people may have other opinions.
Is space travel more about finding resources? Do you think it'll be used more for finding resources for here on Earth, or more about habitation, or something else?
Well, for me, it's more about exploration and learning about our universe. Of course, as you do that, you will certainly find resources, but it'll probably be resources to use out in space rather than to bring back to the Earth. And eventually, I think that we do want to live on other places besides the Earth, but the time scale, could be long there, because it's hard to bring everything that you need to live for a long time, particularly if you're further away than the space station is. And so I definitely think that we should be able to live on places that are not the Earth, but also we need patience because it may take a while. Now, you'll be around longer than I will, so you'll be able to see how that plays out in the next 80 years or so.
Yeah, it would definitely be interesting to see. There's lots of different options, ways that I could see it turning out, but maybe it's none of those.
Yeah, it could be something that no one's even thought of yet.
Any other more notes or opinions you want to share about? Or wait, Mom, you have a question.
I have another one that's forming.
Sure.
Or if something that you're following related to space, something that you love.
Well, the Mars rovers. Well, the Perseverance rover, which is the one that I worked on, it has the ability to core into rocks and take samples and put them into a specially designed, looks kind of like a test tube, and then we seal it up on the rover, and so we've collected over 30 samples of Mars rocks, and it landed in what was once a great lake or bay, and so you can see that it's that there's a place where there was a river delta at one time, and so they've taken rock cores of 3 inches long of different types of rocks, and it's possible that in those rocks, because they went to a place with the most likelihood of the water on Mars isn't there on the surface anymore, and in fact it was several billion years ago with a B that the water all the lakes and oceans on Mars dried up, and so if life formed, the scientists believe that the most likely time was back several billion years ago, and so these are rocks from then, and they're still preserved on the surface of Mars because because there is atmosphere, but it's mild. It's much thinner than ours. There is dust on the surface, and so you need to drill into the rocks. But those are rocks from billions of years ago, and they may have signs of chemical signs, or if you're really lucky, fossil signs of Mars life from earlier times. NASA had started a mission to bring them back called Mars Sample Return, but then the way that they were doing it turned out to be more expensive and more time-consuming than they wanted, and so they've paused that program, and they've asked for several studies as to other ways to do it for lower cost and quicker, and they've got some good ideas. But they collected those good ideas, and then they said that they would wait for the next NASA administrator, which maybe another month or so, to make the decision about how to move forward. When we were building the Perseverance mission, we designed it so that those samples can wait for decades before they come back. I'm sure they will, whether it's 10 years from now, 20 years from now, or 30 years from now. I hope it's not 30. They'll bring them back.
Well, I was curious then, like, what was one of the things that you actually designed or ideas that you put forward when you were working for the Jet Propulsion, what was that? Laboratory? Yeah. How were you involved?
Well, for both the Juno mission that's at Jupiter right now and for the Mars 2020 mission, I'm sorry, the Perseverance mission was called Mars 2020 while we were working on it because it launched in 2020. And now it's called Perseverance. I was the lead engineer on both of those. And so my job was to work with the scientists and understand what they wanted, and work with the engineers and understand what was possible, and then help design the compromises and figure out how we were going to work together to make something possible. When I first started, I was an attitude control engineer, and so my job then was to help design the systems and the software and the algorithms so to point the antennas back at the Earth. That's how I started, was in the control systems that make that work. My first mission was the Galileo mission to Jupiter, and then my next mission was the Cassini mission to Saturn. I was a contributor, not the lead engineer, of course.
Are they, with the new things that they want to propose as far as getting back to Mars, are they exploring different types of fuel, for example, to make it either cheaper or easier or what have you, or is it more based on design of the the equipment?
Well, in fact, they are. All the missions we sent to Mars so far have used chemical propulsion. And in chemical propulsion, what you do is you fire a big engine at the beginning, and then you coast, with course corrections till you get there, and then you fire a big engine again to stop when you got there. Mm-hmm. With electric propulsion, but it used to be called ion propulsion. It still is ion propulsion, but the current term that's usually used is electric propulsion, because the idea that you need very large solar arrays to collect energy, and then you use high power but very low thrust engines that eject ions, and the most common usage that I've seen is xenon. You eject xenon ions out one side of the spacecraft very, very, very fast, but you get very little thrust, but it's very efficient. It's maybe 8 times as efficient as the chemical systems, but because the thrust is so low, you basically have to spiral out to Mars. In other words, you can't get a big thrust. You just you have to get away from the Earth first with chemical, and then you apply a very low thrust for a long time until you get to Mars.
Huh.
So is it more? Is it more energy efficient over time? Like even though you have to like use like a lot of like the whole time instead of just like bursts, is it still more energy efficient?
It is. It's a lot more energy efficient. It can take more time, um, but if you could afford the time, it's much more efficient. If you're doing something where you can take the time, like for example, if you're trying to slow yourself down for a landing, you don't have the time, so you still need a chemical or some other system. So that's how we'll probably get to Mars for one part of the return mission.
That concluded my interview with Doug. My next video on space exploration should be coming out within the next few weeks. Also, consider heading over to my channel page and taking a poll about your own opinions on space travel. Your responses could be featured in my next video. Thank you so much for watching, and I will see you next time.